Today is the first day of spring, the vernal equinox. Flowers are blooming, the days are getting longer and warmer, and with that warm air comes atmospheric instability. Conditions are becoming ripe for nature's most powerful storms to form, tornadoes. Today we are going off the radar and inside the world of modern tornado research and forecasting. First, I'll speak with Katie Morgan, a veteran broadcast meteorologist who has tracked countless tornado warnings live on the air. We'll dive into the communication challenges of covering severe weather in real time. And then we'll turn to researchers working to expand our understanding of tornado formation and behavior. Dr. Sean Waugh from the National Severe Storms Laboratory will give us insight into the latest fieldwork and the goals for tornado warning in the future.
So most of my career has revolved around intentionally finding ways to push the limits of observational technology and really advance our science through increasing our capability to observe it.
I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand the weather and to love it as much as we do. Katie Morgan, thanks for coming on Off the Radar. I'm so excited to have you on finally to talk about some severe weather and tornadoes. And for those who don't know you, you are the chief meteorologist at Fox 17 in Nashville. How long have you been in Nashville now?
I actually just celebrated my 10th anniversary here.
Oh, congratulations. This is a really big role in a very big severe weather market. So I really want to hear about, first of all, your history. You got into this for tornadoes, right? This is your passion.
Yeah, I think when I was in college, I went to the University of Missouri. And yes, I do say Missouri.
That's how you know you're a native, right?
That's right. Yes. No, my mom's family is from Kansas City. So that's how I was raised. University of Missouri, great school, but did a lot of focus in the weather service and industry, and then PhD and going on to more academic fields. And yeah, their focus was severe weather. I think we really were severe weather centric for obvious reasons. We're just right there smack dab in the middle. And we get our fair share of severe weather there in Missouri. So
can you tell me what it's like to be a TV meteorologist covering tornadoes? Because I think a lot of people from home just see maybe somebody cutting into their favorite TV program.
We have a protocol, of course, and we hopefully, 98%, 99% of the time, we know about it well in advance that there's something coming. And we have everyone staffed in a shift where we're almost handing off a baton, like a track race, where we will have someone at the station 24/7 watching radar. When we cut into programming, we're not taking that lightly. But it's essential that we're on the air giving the warning information to those people that we do cover. We have over 50 counties in our viewing area.
Whoa.
So it's a very large area. Our signal, when we cut into programming, we're cutting into all those counties. And it is frustrating. I can understand that. What I like about being in Nashville is the fact that we all work together. And by all, I mean emergency managers, the National Weather Service in Nashville, and surrounding offices, and all the broadcast media, really. We all work really well together to make sure that, we're all playing our roles and giving out that information in a timely fashion.
Have you had any experiences where what you did was fulfilling to the point where you made a difference, or you saved a life because of that warning, because of the information you were conveying on air? Has anybody told you that?
Yeah, I think I've had a few people come up and thank me, and they just, enjoy coverage on day-to-day basis, but more importantly, those times that really count and really matter. But I guess I never feel like I'm doing enough, especially if there's fatalities. It's just, there's a defeated feeling where you automatically go to a place where it's, what didn't I say, or what can I communicate better? Yeah, after every event, I go through that. I think, what can I do better to communicate?
And you're on the front lines here of communication. So, if you kind of go back, you mentioned the National Weather Service, you mentioned the emergency managers. And you keep going back, you get to NSSL and the National Severe Storms Laboratory, who's doing amazing research right now that is, I don't know if you've seen it in your career, I'm sure you have. I have this drastic difference in the ability to warn. I mean, if you think back to the day of warnings being these massive areas, like whole counties put under warnings, now they're so much more specific and they're so much better. The lead time is so much better. And it's because of that research that's being done several levels back at NSSL. I did talk to one of the researchers at NSSL. His name is Sean Waugh, and he is doing very cool research. Some of it gave me major Twister vibes. But he's doing very cool research, like strapping mesonets onto a truck and driving to storms.
Amazing.
Yes, I know. It sounds very hardcore.
No, when we get into meteorology, I think that's all our dreams.
We all think that we're doing that, yeah.
That's what we're going to do, right?
There's a whole new generation of meteorologists that's about to happen, and it's all those kids who are like 14, 15 right now, because Twisters is coming out this summer, and they're all going to get like that adrenaline thrill off of the movie, and they're all going to want to become meteorologists just like our generation did.
It's a whole new generation.
For sure. So we talked about that too, because they were actually heavily involved in the movie Twisters that's coming out this summer.
Oh, cool.
So there's so much of it, and he couldn't share too much information yet about the movie, but he said there's so much work that went into making sure that it was based on real information, real research that's being done at the Severe Storms Laboratory right now. So we get a little insider information on that. And then also some really cutting edge hail research that they're doing there too. So really cool stuff. He's a super nice guy. He was a lot of fun to talk to. But Katie Morgan, thank you so much for all you do, keeping people safe. And thank you for your time today coming on the podcast as well.
Of course. Thanks for inviting me. This was fun.
Now here's my chat with Dr. Sean Waugh from the National Severe Storms Laboratory. All right, Dr. Sean Waugh, thanks for being on today. So much going on at NSSL, and I think a lot of people maybe don't even know what NSSL is. So we're going to get a little background on the agency itself and what you guys are doing there. But I want to start with you. Can you tell me about your history, your background, where you went to school, what your specialties are?
Perfect. Yeah. So I'm a research scientist at NOAA's National Severe Storms Laboratory, and I've actually been in Norman at this point for probably close to 20 years. I grew up in South Central Kansas, a very small town called Arkansas City. It was really great to me. It encouraged me a lot. I had a lot of, great interactions in my childhood, and weather and like severe weather in particular has always been one of those things that I've just always been fascinated by. I've always been interested in. My earliest memory, my grandfather had a farm up in North Central Kansas. And my earliest memory, I was probably 4, maybe 5. He was really worried. There was a hailstorm that was kind of coming through, and he was pacing back and forth because he had a lot of wheat crop at the time. And, he was worried that it was going to destroy his crop, and ended up not happening, which is good. But he was very upset, we'll say. He's using some colorful language at the meteorologist that was on TV. And he was like, these guys are never right. I don't know why I listened to them, that kind of thing, which I've heard a lot in my career and things like that. And I stood up at 4 years old, and I was like, Grandpa, I'm going to grow up. I'm going to be a meteorologist, and I'm going to be right all the time. And he was like, well, you're going to make a lot of money because you're going to be the only one, and everybody will listen to you. And it's just, it's something that stuck with me. So I actually, when I, decided to go to college, I had a lot of options. Obviously, there's a lot of great programs out there, but OU was kind of like near and dear to me because I'd heard so many great things about it. I knew that, the Weather Service office was down here, and it was this really great program to come to. So I came down to OU, and I had this very limited understanding of what meteorology was. I knew about the people you see on TV, and then I knew about the Weather Service. And that was it. That was the extent of my knowledge of the field of meteorology. I just assumed naively that we had everything figured out. And I came down to OU, and it was just this explosion, right? There's so much work still to be done, and there's so many questions that we still have. And I didn't even know about the research side, and I just absolutely fell in love with it. So I spent 12 years at OU. I got 3 degrees. All of my degrees are in meteorology. And then 99% of what I do at work is probably all engineering based. So, it's a very fun balance between what school taught me and then what I've taught myself over the years. But it's something that I really love, enjoy.
Interesting. Did any of the research that you did in college translate into the work that you do at NSSL?
Absolutely. As you progress through school, you've got capstone projects and master's theses and, dissertation work, that sort of thing. My master's project was actually designing a instrument shield that we use today on our mobile vehicles that I kind of discovered, like the one that we were using at the time had a problem with it. And it was a system that we'd been using for maybe 20 years and nobody had really taken a really like deep, like in-depth look at it and identified some shortcomings, things that I didn't necessarily like. So I ended up redesigning it and creating a new one. That was my master's project. And, we're still using that today. And, there's a paper out on it. And I try to encourage everybody that, will listen to me talk about it to, hey, you should use this, especially if you're doing, mobile severe weather operations. And then my dissertation work went a completely different direction. It's still an instrument. I created a new instrument, but it's more microphysics based. So looking at like raindrops, snowflakes, hailstones, frozen grasshoppers, whatever happens to be there. But it's at altitude, right? Because like it's in the cloud. It's in places that we can't take those observations with a plane. So I developed a system that basically goes up on a balloon to take those observations for us. And we still use that in a number of field projects because it's really the only way that we can get that information. So most of my career has revolved around like intentionally finding ways to like push the limits of observational technology and really advance our science through like increasing our capability to observe it.
Okay, so I have to ask, how old were you when Twister came out, and what was your reaction to like Toto, or I guess it's Dorothy is what they called it in the movie?
Toto's the real version
thing, right?
Yeah. I don't actually remember. When did that come out? 96?
96, I want to say.
Yeah. So I was 10 at the time. Of course, I loved the movie. I still love the movie today. It's one of those things that like most meteorologists, like it's a cult following, right? Like we all like secretly watch it. There's a lot of inaccuracies with it. There's a lot of things that, as meteorologists, we look at and we just, shut and hide your eyes, right. Shudder away at it. But it's an amazing movie and it's a lot of fun. And there are a lot of people that I know that like got into meteorology because of that movie.
Yeah. I'm one of them. Yeah.
When I saw it, I watched the observational stuff in it now, like that's really exciting stuff to me because like, the premise behind it is there's this big question, how do tornadoes work? And we're trying to understand that. And that's real work that we're still doing today. And, sure, the Hollywood movie, dramatizes it and, the Pepsi cans and all that kind of stuff. But, there's real research, there's real science that kind of drove a lot of that, just like there's real research and real science that is driving a lot of the script on the new movie.
Do you have any information you can share about the new Twisters movie?
It will be a lot of fun. It is a Hollywood movie, so it's going to be dramatic. It's exciting. It's high octane. It's very energetic. But I will say that there was a tremendous amount of effort put into it to make the film as real as possible. It ties into a lot of current real research that's going on in the scientific community. It's got a lot of themes in it. It's got a lot of great callbacks to the original movie. I was very involved with it, and that's probably the most that I can say right now. But it's a lot of fun, and I can't wait to see everybody's reaction to it when it comes out later on this summer.
Are you gonna get to like go to the premiere or see it ahead of time?
I hope so. Yeah. Like I've heard people that are like renting out movie theaters and like trying to get everybody to go and things like that. There's a lot of exciting stuff, and in the next couple of weeks to months as we lead up to it, I think we're going to see a lot more like promotion stuff coming out for it and things like that. So it's going to be really exciting.
Cool. Can we check in with you after it comes out?
Absolutely.
Okay. We'll do like a side-by-side. Was this real? Was this not real? Cool. All right. So let's talk about what is real and what's going on at NSSL right now. You guys have so many projects. I guess my first question is, who's in charge of coming up with the acronyms? Because this is so many acronyms and they're very wordy, but they're also like kind of relevant to weather terms. So I'm curious who actually gets to do all that naming.
Yeah, we joke that any good research project, the first task that you have to do is you got to come up with an acronym, and then you basically fill in the blank for what fits the acronym, right? And we've had some great ones over the years. The original Vortex project back in the early 90s, Vortex, it was studying tornadoes. Like that set the bar, right? Like how do you get a better acronym than that? But there are a lot of really good ones. Project names and experiments and things can get kind of long, especially when you're trying to be descriptive. So the acronyms are kind of a fun way to do that. And that is one of the early like kind of steps in doing that. And if you want to look at the fun side of it, the people that are involved with the project, we've got so many different research, tasks going on and focus points and things like that. There's all these different groups that are in the lab and they have the ability to kind of come up with those names. And, it's a fun, kind of like group effort to try to come up with that, but they're also very meaningful. The idea is to try to convey something about what the project's doing quickly, something that's easy to say and discuss and things like that. Because, our primary goal at the lab, with the National Severe Storms Lab is to not only understand severe weather, but to communicate that understanding back to the public and to the people that are going to use that information, like the Weather Service and the Storm Prediction Center and things like that. So we have to be really good at communicating what we're doing, and that starts with a really good name.
I want to talk about some of these projects because some of them are like you're years into them at this point. So I'm curious, tornado research-wise, what you've been working on in recent years and what has come of it.
Right. So, if you go back, 20, 30, 40 years, back into the 60s, 70s, that kind of thing. I guess that's more than 30 or 40 years ago now. But, average tornado warning lead time was very short, right? Like our understanding of severe weather and tornadoes in particular, we've come a long way since that time. And one of the biggest advancements that we've made is in the, tornado warning lead time. We've gotten really good at predicting large scale, generic type environments that are supportive of storms that are likely to produce tornadoes. But one of the challenges that we face now is that, we may have an environment and say there's 4 or 5 different storms and they're all in the same environment and one of them is producing a tornado and one of them isn't. Or one of them is producing a very small tornado that's very weak and it's not on the ground for very long. And then the storm down the road, 20 miles away, that tornado's been on the ground for 3 hours and is 2 miles wide, that sort of thing. We don't understand those differences. We don't know what causes one storm to produce that significant hazard and one storm not, even when they're in the same environment. And that's been the focal point of the last probably 5 to maybe 15 years or so, is actually like really honing in on like the fine scale details on the individual storms and trying to understand how those environments are producing those hazards. And some of that is based off of, past work and past observational work, looking for features and storm structures and things that we think are driving that. And then there's also the advancements in computer technology that we've had that have driven a lot of that research as well. Computer models have really come a long way in the last year. You're seeing nowadays like what we can do with AI and, all these crazy things. And we're actually incorporating that into a lot of the algorithms and products and things that we're developing. But some of those computer models are hinting at features in storms that we didn't necessarily know 20 or 30 or 40 years ago that they existed. So we're actually going out and we're trying to observe those features, trying to understand why is this storm producing a tornado and, what's causing it to be so big and, on the ground so long and what causes it to dissipate. Those are the kinds of questions that we're after now.
Interesting. So do you think that tornado forecasting will go in the direction, and is this a goal of it being more precise, not just tornado in your area within the next 10 minutes, or this is the path, but rather this could be an EF3 or above, or this could be a, this width or this, length of time? Is it going to get that precise, you think?
Obviously, that would be the goal, right? Like we would love to be able to give people an hour's lead time on, a block by block type scale of where we think, this type of an event is going to happen. And, maybe we're going to get there someday, but there's a lot of steps that we got to go through to get to that kind of process. Forecasting, whether there's going to be a tornado, 15 minutes out, 30 minutes out, an hour out. That's a challenge. Narrowing that cone so we're not including as many people in, an unnecessary warning type thing. We spend a lot of time looking at, the success rate of our tornado warnings, but also the false alarm rate. That's a really big issue. If we put you in a tornado warning 10 times and there's not a tornado, you're going to stop paying attention at some point, right? And we don't want that. So we're really trying to, fight back on the false alarm ratio and try to get our warnings as precise and as accurate and as timely as we can to try to give people as much of an advantage and, ability to react as we can on things. And there's a lot of work that goes into that type of stuff. So absolutely. We would love to get to the point where we can tell you, 2 hours from now down to this block, there's going to be a tornado and it's going to be at this strength. And, those are the kinds of questions that, we're shooting for.
Yeah. And then you've got this whole added feature of communication too, of like, how do you convey that to the public? So I know like the Weather Service is doing some modification to their communication as far as like use of advisories. What's the communication line? I guess I'm curious between, say, you guys, the researchers, and then with the forecasters, and then with like the broadcast meteorologists. Is there good communication among those different groups?
Absolutely. We can sit here and we can study severe weather, all day long and understand and learn as much as we can. But if we're not communicating that back the broadcast meteorologists that are on TV warning everybody, and the Storm Prediction Center and the National Weather Service that are creating those products and creating those warnings to get disseminated. If we're not maintaining that communication link, then we're failing, right? Because we're not communicating that effort forward. So we actually have an entire program dedicated to that. I mean, the Hazardous Weather Testbed is an amazing example of that, where we actually bring in external partners, whether that be weather service, forecasters in different areas of the country, broadcast meteorologists, emergency managers, whatever, to basically interact and be that bridge, that development kind of like test bed where we can try out new products. Is this useful? Is this not useful? Is this something that you need? What can we do to try to increase your ability to take that information, disseminate it down into something that you can use, and then apply that to, the real world, which is ultimately to protect lives and property. We have an entire program dedicated to that. And the team that is responsible for that and the people that, run that on the day-to-day operations, like it is an incredible feat to try to organize. I mean, just logistically to try to get all that together, let alone the material that they produce. I mean, it's a fascinating and amazing program.
It is cool. And it's also cool to think about what you're doing. And I think people don't realize how basic some of the science is. When I was looking at your videos of like people sending the little balloons up with the little styrofoam cups, like that looked like a children's science project.
Yeah. I mean, at the end of the day, like a lot of our observations, I mean, it's basic things. It's the same things that you can measure in your backyard, right? Temperature, pressure, wind speed, wind direction, relative humidity. But it's where we take those observations that's the challenging aspect. I mean, we have surface stations and observing sites all over the country and all over the world that give us that information. But we need that information like in really specific spots, inside severe weather or, in close proximity to a tornado or vertically up through the storm. And knowing that information, even though it is rather basic, like that's the ingredients that are feeding the storm, right? So if we know what's driving it, we can ultimately figure out what's causing the hazards.
Mm-hmm. And tornadoes are kind of what nightmares are made of, but you guys are handling a lot of other severe weather types. What other work are you doing? Because you handle floods and hail. What else are you studying?
I mean, we basically study the whole gambit, the whole spectrum of severe weather, whether that be tornadoes, lightning, hail, hurricanes. We have to drive a little further for hurricanes. We don't get too many of those here in central Oklahoma. So we gotta drive to the coast for those. But I mean, that is a severe hazard. And hurricanes also, they have flooding and they have storm surge. They can also produce tremendous amounts of tornadoes, especially in the outer rain bands as they're making landfall. So we study all of that. I mean, we've got groups that go out into the mountainous regions in the West and study debris flow based on, heavy rainfall patterns and how that impacts, irrigation channels and stream beds and things of that nature. We've done projects where we look at lake effect snow bands. We did one 2 years ago, last year, where we actually went up to the east side of Lake Ontario and studied lake effect snow bands, which was a lot of fun for me because like growing up in Kansas, the most snow I'd ever seen at one point was like 6 inches, maybe. And the first event that we worked up there, I dumped 4.5 feet of snow. So it was very entertaining for me. But those snow bands produced lightning, and that lightning, has a tendency to strike the wind turbines that are up there. And, companies want to know that kind of stuff. Are the wind turbines getting struck for a reason? Is it just bad luck? That sort of thing. So there's all kinds of research that we do in all of those facets.
You guys are doing research. Do you do any forecasting at all?
So a lot of the forecasting that you see, from like the Weather Service perspective comes from the National Weather Service. The daily outlooks, as far as like, large scale regional type outlooks about severe weather and things like that, comes from the Storm Prediction Center. And we work closely with them, but that's their job to kind of take that knowledge and, create those forecasts that you see. Now, we do kind of bridge into that because we have programs like the Warn-On Forecast System that we're working on here at the lab to actually take some of that kind of experimental knowledge that we have and like blending in real-time observations and running very high resolution models and using that as kind of an experimental product to help like create those warnings and watches and, all that information that comes out. So we bridge with that, but it's not necessarily like the National Severe Storms Lab's job to produce that warning information. That's the Weather Service's job, and they do a phenomenal job at it.
That was one thing in Twister. I remember the first time I had ever heard NSSL was in Twister. They were like, NSSL says, and they shouted out a forecast. And I was like, ooh, what's that? And I remember researching it. That was the first time I'd ever heard of it. Cool. Very, very cool. Where can you tell me, for those who don't know and have never heard of NSSL, where are you located? Can people come visit? Because I'm expecting this is just like a cool lab where all sorts of crazy stuff's going on. Can people come watch?
Absolutely. So the National Severe Storms Laboratory is located in Norman, Oklahoma. We're actually located on the southern end of the University of Oklahoma's campus here in Norman. And there's an entire building basically that we have dedicated to weather research. And the National Weather Center was specifically designed for that purpose. And in order to accomplish that goal, not only are we in the building, but the University of Oklahoma School of Meteorology is in here. The Norman's, WFO, the Weather Forecast Office from the National Weather Service is in here. The Storm Prediction Center is in here. Our Cooperative Institute is in here that does a tremendous amount of research and, helps us with a lot of our work as well. I mean, there's so many different partners. There's private agencies that are around the area. I mean, it's basically a mecca of weather research in all aspects. And you can absolutely come visit. You can tour the building. You can see all these spaces. You can come down to the vehicle bay and find me and whatever, weird thing that I'm working on. I mean, we had a bunch of groups come through last night, actually, and I had an opportunity to kind of talk to those. And it's always neat because, like, when you come through, you never know what you're going to see. And for example, if you show up right now, you'd be seeing me like in the development stages of the hail camera system that we're working on right now to try to push that observational limit forward on hail research and, how do we observe hail and things like that. So there's always exciting things going on.
Yeah. Can you tell me more about that, about how you're using cameras to monitor hail and why it's important to monitor it falling instead of just picking it up from the ground?
Right. So we here in Oklahoma experience a lot of hail. If you ask people around here, like, what's the biggest hailstone you've seen? Most people, I think the minimum is probably like 2 inches.
Wow.
The biggest one I have personally experienced is probably about 6 inches.
Oh my gosh.
So the hail occurs, all over the world. And most people at some point in their life have either seen it or experienced it. And it also causes a tremendous amount of damage. It's one of the costliest, weather phenomenon as far as a damage perspective goes, because it can be so damaging and so widespread, right? The problem with a lot of hail research is that up until recently, all of our hail observations are post-impact, right? So it lands, it falls, it stops hailing, and then you walk outside, when it's safe to go outside. It's melted, it's broken, it's not the same hailstone that it was, right? So you take a picture of it and you're like, oh, it's a 4.5 inch diameter hailstone that, created this big hole in my front yard. Sure, that's what it is now. How big was it 20 minutes ago when it landed? What broke off? What's changed since then? We don't really have good estimates of fall speed. How fast are these sorts of things falling? Do they move with the wind or they just kind of rocket through it, right? What do they look like? What are the spikes? Is it melting? Where is the water? I mean, these are all really like basic questions, but they're very important questions because if you're using a radar to try to observe hail at a distance, you really need to know how those hailstones are going to look in order to determine like what you're looking at on radar, right? So what we're doing currently at the Severe Storms Lab is trying to develop a system that's capable of observing hail in complete free fall before it hits anything. And to do that, we need an incredibly fast camera system. So we actually have 2 cameras that are sitting in the bed of the truck, kind of pointed inward. So they're focused on basically the truck bed. And they shoot 4K footage at 330 frames a second. So with that, we can capture stones not only in like an instant where it's not moving, it's not blurring, just a nice clean image, but we can track it from one frame to the next. So we can get size information, velocity information. Is it rotating? We can see water droplets shredding off of it. I mean, the detail that we've gotten with this system is absolutely groundbreaking. I mean, it's just fundamentally going to change how we take hail observation. It's going to address so many of those questions. The challenge with that is I need a ton of light to do it. So there's a huge lighting system on the back. And I mean, it's objectively twice as bright as the sun at the surface of the earth. So like, I hope nobody's parked behind me when I turn this thing on because it's very intense.
And then also like, what's it doing to the truck? How many trucks have you gone through?
So the fun aspect of the trucks, the vehicles that we use, obviously, you can see pictures of the mobile mesonettes. There's hail cages on them. They still have dents, but we designed the vehicles and the equipment that we have to try to survive the environments that we're putting them into, right? Like we're intentionally driving into some of the most hostile conditions on the planet. We need our equipment to survive. And more importantly, we need to be safe doing it, right? So we spend a tremendous amount of effort making sure we have crossed every safety bridge we can so that, we're not putting ourselves at risk. So the trucks themselves, they get pretty beat up over the years. They're actually rental cars. We rotate them out every 4 or 5 years. And I always get a lot of questions at the end, like, what are you doing to this? Why are there so many dents and holes in the side mirrors and things like that?
And like, how many windshields do you go through? Or do you have like a special windshield that's hail-proof?
So the original ones that we used, we went through a lot of windshields almost daily. At one point in a project back in 2009 and 2010, I ended up breaking 3 windshields in 2 vehicles in 48 hours. Just because, I mean, that's the environment that we're operating in, right? That's a safety hazard. It gets expensive replacing windows. It's logistically very difficult. So the hail cage that we have now is designed to protect that front windshield, at least from the point of completely shattering out. Most of the bigger stones, they tend to fall straight down. So the hail cage protects us from that. We've got some blast film that we're going to be putting on the side windows to try to protect those, add a little bit of strength and integrity and that sort of thing. We've looked into things like Lexan, bulletproof glass, that kind of stuff. You run into issues where like it fogs up and then you can't get it to unfog, or bulletproof glass still breaks on the outside. It just doesn't go through. So there's a lot of different ways that, I've seen people try to tackle that problem, but it's something we pay a lot of attention to.
Sean, is there anything else you want to add about NSSL or the research that you're doing?
I mean, the only other thing that I would add is, the Severe Storms Lab's main goal is to try to understand, all aspects of severe weather and how it affects us and how we can get better at providing information to the public to try to save lives and property going forward. And it's a tremendous effort to try to do a lot of this research. But we can only do that research, if it's serving the community. And I absolutely encourage people to come out, look, ask questions. If you see us, stop, say hi. Hey, what are you doing out here? We get a lot of comments and questions from people when we show up. They're like, should I be worried? Like you're in my backyard. Like, I don't like that you're here because now I'm afraid that there's going to be severe weather. But I just asked, just talk to us, because like that engagement with the community is something that I think we really strive for and really helps us do our mission, because it kind of helps focus on what, the community is concerned about, So absolutely come and talk to us. If you ever have any questions, say hi, come by the Weather Center, shoot us an email, whatever that is.
Cool. Dr. Sean Waugh, thank you so much for your time.
Absolutely.
Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts or Spotify or wherever you listen to podcasts. New episodes publish every Tuesday. If you know someone that's interested in severe weather and tornado research, please share this episode with them. We'd also love you to rate and review us on Apple Podcasts and Spotify. Let us know what you think of the show and give me ideas for future episodes. Special thanks to Katie Morgan for joining me at the beginning of the episode, and to Dr. Sean Waugh for his expertise. I'm meteorologist Emily Gracie. Make it a great day.